the impending revolution. We are on the verge of a revolution as bold as the discovery of relativity by Einstein. They are emerging at the border of science, new ideas that challenge everything we believe about the way our world works and how we define ourselves. Discoveries are being made that prove what religion has always maintained, that is, that human beings are far more extraordinary than one group of flesh and bones. In its essential basis, this new science answers questions that have left scientists puzzled for hundreds of years. In its deepest part, it is a science of miraculous. For several decades, respected scientists from various disciplines around the world have conducted well-designed experiments whose results contradict current biology and physics. Together, these surveys provide us with copious information about the central organizing force that governs our body and the rest of the cosmos. What they found is nothing short of impressive. In our most basic essence, we are a power load. Humans and all living things are a coalescence in an energy field connected to all the other things in the world. This pulsating energy field is the central mechanism of our being and our consciousness, the alpha and omega of our existence. There is no duality, I and non-self of the body in relation to the universe, but only a single fundamental field of energy. This field is responsible for higher functions of our mind, the source of information that guides the growth of our body. It is our brain, our heart, our memory, in fact, it is a world of design for all eternity. The field is a strength, not germs or genes, that determines whether we are healthy or sick, the force that must be used so that we can be healed. We are connected and involved with our world, we are his inseparable, and our only fundamental truth is our relationship with him. The field, as Einstein once called him briefly, is the only reality. So far, biology and physics have been servants of the concepts advocated by Isaac Newton, the father of classical physics. Everything we believe about our world and the place in it drift formulated 17th-century ideas, but they still form the backbone of modern science, theories that feature all the elements of the universe as being isolated from each other, divisible and independent whole. These conceptions, in essence, create a division of separation world. Newton describes a material world in which the individual particles of matter follow certain laws of motion through space and time, or the universe as a machine. Before Newton formulated his laws of motion, the French philosopher René Descartes presented an idea that at the time was revolutionary, that we represented in our minds, we were separate this inert and lifeless our body's matter, it was just another kind of machine well lubricated. World was composed of a small load distinct objects, which behaved predictably. Most of them were separated from human. We sat outside this universe and we looked inside. Even our body was somehow separate and different way of our true self, the conscious mind that made the observation. The Newtonian world might be law-abiding, but ultimately was a lonely and desolate place. The world moved on, a wide gearbox, whether we were present or not. Through some clever measures, Newton and Descartes had plucked God and the life of the world of matter, and removed ourselves and our consciousness from the center of our world. They ripped the heart and soul of the universe, leaving in its wake a lifeless collection of intertwined parts. Most important of all is that, as noted by Danazor in The Quantum Self, Newton's vision took in the structure of the universe. Our self-image became even bleaker with the work of Charles Darwin. The theory of evolution, now somewhat refined by neo-Darwinists, it is the theory of a random life, predatory, meaningless and lonely. To survive, you simply have to be the best. You nothing more than an evolutionary accident. The vast and complex biological heritage of our ancestors is laid bare to be reduced to a central aspect, survival. Eat or be eaten. The essence of the human condition is a genetic terrorist who escapes effectively any weak links. Life does not consist in sharing or interdependence. Life comes to win, come first. And if you can survive, it is at your own at the top of the evolutionary tree. These paradigms, the world seen as a machine, and man as a survival machine, led to a technological field of the universe and at very little real knowledge that shut down any fundamental importance to us. On a spiritual and metaphoric level, they caused a desperate and brutal sense of isolation. nor led us closer to the most essential mysteries of our existence, how we think, how life begins, why we get sick as a single cell turns into a fully formed person, and even what happens to our consciousness when we die. Remain reluctant apostles. These worldviews like that mechanized and separate, even if it is not part of our usual experience. Many of us seek to protect what we see as the adverse and nihilistic fact of our existence in religion, which can offer us some help with their ideals of unity, communion and purpose, but through a worldview that contradicts the view held by science. Anyone seeking a spiritual life must fight with these opposing worldviews and try, fruitlessly, to reconcile them. This world of separation should have been destroyed once and for all by the discovery of quantum physics in the early part of the 20th century. When the pioneers of quantum physics scanned the essence of matter, they were impressed by what they saw. The tiniest fragments of matter were not even matter, as we know, they were not even something fixed, but sometimes one thing and sometimes quite another. And stranger still is that they were often many things possible at the same time. However, the most important is that these subatomic particles alone did not have any sense. Only meant something if they were related to everything else. In its most basic essence, the matter could not be broken into smaller independent units, being completely indivisible. It was only possible to understand the universe as a dynamic network of interconnections. Things that at some time been in contact always remained in contact throughout the space and all the time. In fact, the time and space arbitrary concepts appear to be not applicable to this level over the world. In reality, time and space as we know them did not exist. All appear, as far as the eye could see, was a long scene of the here and now. The pioneers of quantum physics, Erwin Schrödinger, Werner Heisenberg, Niels Bohr and Wolfgang Pauli, had a hint of the metaphysical territory they had violated. If the electrons were connected simultaneously everywhere, this indicated something profound about the nature of the world as a whole. Scientists have turned to classic philosophy texts in trying to understand the deeper truth about the strange subatomic world who were watching. Pauli examined psychoanalysis, archetypes and Kabbalah. Bohr, the Tao and Chinese philosophy. Schrödinger, the Hindu philosophy. And Heisenberg, the Platonic theory of ancient Greece. Nevertheless, a coherent theory of the spiritual implications of quantum physics remained beyond the reach of these scholars. Niels Bohr hung a sign on her door that read "No entry philosophers. People working." Quantum physics contained another matter very practical and unfinished. Bohr and his colleagues have advanced only to a certain point in their experiences and understandings. Experiments were performed to demonstrate that these quantum effects occurred in laboratory with subatomic particles lifeless. From there, scientists who succeeded them departed from the principle that the strange quantum world only existed in the world of lifeless matter. Any living things still work according to the laws of Newton and Descartes, this conception that inspired the whole modern medicine and biology. Even biochemistry depends on the Newtonian force and the collision to work. And what about us? Suddenly, we had become fundamental to all physical processes, but no one recognized this fact fully. Quantum pioneers had discovered that our involvement in the matter was crucial. Subatomic particles exist in all possible states until the perturbed SEM was watching them or measuring them, and at that point, after all, they are stabilized into something real. Our observation, our human consciousness, it was absolutely crucial for this process of fact. Subatomic flow became something definite, but were part of the mathematics of Heisenberg and Schrödinger. They understood that we were in some very important way, but did not know how to include. When it came to science, we were still on the outside looking in. The loose ends of quantum physics have never been tied into a coherent theory, and quantum physics was reduced to a highly successful tool technology vital to the manufacture of pumps and modern electronics. The philosophical implications were forgotten, and all that remained were the practical advantages. Most of today's physicists were willing to accept, without further analysis, the bizarre nature of the quantum world, for the mathematical processes such as the Schrödinger equation function quite well. But shook his head at the quality counterintuitive to everything. How could the electrons being in touch with all at the same time? How could an electron is not a definite thing while it was not examined or measured? How could actually be anything concrete in the world, was illusory, so we began to examine it more closely. Their response was to say that there was a single truth for all that was small and one for all that was much greater, true for living things, one for inanimate things, and accept these apparent contradictions in the same way as we might accept a basic axiom of Newton. Those were the rules of the world and should simply be accepted without argument. The math works, and that's all that matters. A small group of scientists scattered around the planet was not happy to continue automatically dealing with quantum physics. They demanded a more appropriate response to many of the big questions that were left unanswered. They continued with their investigations and experiences from the point where the quantum physics pioneers had stopped and began to take a deeper look. Several of them have rethought some equations that always had been discarded in quantum physics. These equations correspond to the zero-point field, an ocean of microscopic vibrations in the space between things. They realized that the zero-point field were included in our conception of the most fundamental nature of matter. The universe would support a busy sea of energy, a vast quantum field. If that were true, it would all be connected by something like an invisible web. They also found that we're formed by the same basic material. At the most fundamental level, living beings, including humans, were quantum packets of energy constantly exchanging information with this inexhaustible sea of energy. Living things emitted a weak radiation, and this was the most crucial aspect of biological processes. The information about every aspect of life, from cellular communications to the vast array of DNA controls, were relayed through an exchange of information at the quantum level. Even our minds, that others supposedly so extrinsic to the laws of matter, operated according to quantum processes. The thinking, feeling, every higher cognitive functions, were related to quantum information pulsing simultaneously through our brain and our body. Human perception was due to interactions between subatomic particles of our brains and the sea of quantum energy. Resonates literally with our world. The findings of these scientists were extraordinary and heretical. At one time, they challenged several of the most basic laws of biology and physics. May have discovered nothing less than the key to all the processing and exchange of information in our world, communication between cells in the manner of seeing the world as a whole. They suggested answers to some of the deepest questions of human biology and morphology of living consciousness. Here, in the so-called dead space, possibly lay the key to life itself. They provided evidence that we are all connected to each other on the basis of our being. They demonstrated through scientific experiments that there may be a vital force circulating around the universe, something that has been alternately called collective consciousness or, as theologians called it, of the Holy Spirit. These scientists presented a plausible explanation for all areas in which mankind has had faith over the centuries. In a way, they offered us a science of religion. Unlike the worldview of Newton or Darwin, the prospect of these scientists stimulated life. Were ideas that could strengthen us with their implications of order and control. We were not simple accidents of nature. It had a purpose and a unity in our world and the place we occupied it, and had a considerable influence in all this. What we did and we thought it was important. In fact, it was instrumental in the creation of our world. They were not separated from each other humans. There was no us and them. No longer we were on the edge of the universe, from the outside looking in. We could take our rightful place, return to the center of the world. These ideas were the substance of betrayal. In many cases, these scientists had to fight a defensive battle against a dominant group, obstinate and hostile. These investigations have been going on for 30 years, largely unrecognized or restrained, but not because of the quality of work. Scientists, all from reliable institutions such as the universities of Princeton and Stanford, the best institutions of France and Germany, have experimented clean. However, such experiments attacked several principles considered sacred and situated in the heart of modern science. They did not fit the prevailing scientific view in the world seen as a machine. Recognizing these new ideas would require got rid of much of what modern science believes and, in a sense, we started from scratch. the old guard would not hear of these theories, which did not fit the worldview them and therefore were necessarily wrong. However, it is too late. The revolution is irreversible. Scientists were highlighted in field are just some of the pioneers, a small representation of a larger movement. Many others are coming in their tracks, challenging, testing and modifying their views, involved with the work to which all true explorers are involved. Instead of discarding this information as inadequate under the scientific view of the world, the orthodox science will have to start adapting their conception of the world so that it becomes appropriate. It is time to relegate Newton and Descartes to their proper places, that is, the prophets of a historical view today surpassed. Science can be a process that seeks to understand our world and ourselves, rather than a fixed set of rules eternal. And with the introduction of the new, the old must often be discarded. The field is the history of this revolution is brewing. The similarity of many revolutions, started with small pockets of rebellion, which gathered individual strength and momentum, a revolutionary breakthrough in one area, a discovery elsewhere instead of a large, unified reform movement. Although aware of each other's work, are men and women who live in their labs and they often do not like to venture beyond the experience to examine all the implications of their findings or that do not always have the time to put them in context of other scientific evidence. Each scientist participated in a journey of discovery, and each found a piece of land, but none of them was brave enough to declare it a continent. 1. The universe resonate. Light in darkness experience with PES astronaut Mitchell. What happened while Ed Mitchell was perhaps caused by the absence of gravity, or perhaps by the fact that all his senses were disoriented. He was on the way home, which at the time was about 400,000 kilometers away, somewhere on the surface of the cloudy sky blue and white crescent that appeared intermittently in the triangular window of the command module of Apollo 14. Ed he liked to think of himself more as an explorer than as test pilot, a kind of seeker of truth of today. His attraction to science struggled the whole time with burning Baptist fundamentalism of his youth. It did not seem to have been by chance that he had grown up in Roswell, New Mexico, where aliens were first seen, only 1.5 kilometers from the house. Robert Goddard, the father of astronautics. Science and spirituality coexist in him, vying for primacy, but Ed wanted them somehow clench hands and do the pace. Then, as he looked out of the Kitty Hawk command module window, Ed experienced the strangest feeling that would never have in life, a sense of connectedness, as if all the planets and all people at all times were connected by an invisible web. He could hardly breathe because of the grandeur of the moment. Although he continued to turn knobs and push buttons, it was far from the body, as if someone else were doing the navigation. A huge force field seemed to be present, always calling everyone with their intentions and thoughts, and all animate and inanimate forms. Anything he did or thought would influence the rest of the cosmos, and any event this would have a similar effect on him. Time was just an artificial concept. All he had learned about the universe and the separation of people and things seemed wrong. There were no accidents or individual intentions. The natural intelligence that will continue to exist for billions of years, which molded the molecules of his being, was also responsible for the current journey. This was not something he was just noticing in your mind, but a gut feeling, as if physically spreading out the window, toward the farthest reaches of the cosmos. He had not seen the face of God. It looked more like a blinding epiphany of meaning than a conventional religious experience, what Eastern religions often call unit of ecstasy. It was as if, in a single instant, Ed Mitchell had discovered and felt the force. There was another thing he had refrained from telling his companions in Apollo. Later that night, Ed quietly resumed what was a seamless experience throughout the journey to the moon and then toward the Earth. Lately, he had been engaging in experiments with consciousness and extrasensory perception (ESP), devoting some time to the work of the study Dr. Joseph B. Rhine, a biologist who conducted many experiments on extrasensory nature of human consciousness. Two of his most recent friends were doctors who had conducted experiments worthy of credit about the nature of consciousness. Together, they understood that Ed's trip to the moon was offering them a unique opportunity to verify that human telepathy could occur at distances greater than those of drive. Laboratory. Rhine. they were faced with a rare opportunity to see if this type of communication could extend beyond any possible distances on Earth. 45 minutes after the beginning of the sleep period, as did the 2-day trip to the moon, Ed took a small flashlight and, playing his clipboard, copied some numbers at random, each of which corresponded to Zener famous symbols of Dr. Rhine, square, circle, cross, star and pair of wavy lines. So Ed is intensely focused on them, methodically, one by one, trying to broadcast your choices to colleagues on Earth. Even though extremely encouraged by the experience, he kept to himself. Once tried to have a conversation with Alan Shepard, commander of the Apollo mission, about the nature of consciousness, but it was not very close to his head, and that was not the kind of subject that inspired others as much as he. Some of the astronauts had thought of God while in space, and everyone in the space program knew they were looking for something new about the way the universe worked. But if Alan and Stuart Roos, a pilot of Apollo mission, knew that Ed was trying to convey thoughts to people on Earth, they would have thought he was even more eccentric than ever imagined. Ed closed the evening experience and would do it the next night, but after what happened to him earlier, hardly seemed necessary to repeat them. He now had his own inner conviction that it was all true. The human minds are interconnected, as we're connected to anything else in the world and in all other worlds. Its intuitive part accepted this fact, but for the scientist inside him that was not enough. Over the next 25 years he would turn to science, waiting for her to explain to him exactly what had happened to him on that trip. Paradigm shift. A fantastic experience of Edgar Mitchell in the space left tiny cracks in a large number of their belief systems. However, what most bothered Ed about his experience in space were scientific explanations of biology, particularly about consciousness, which now seemed impossibly reductive. Despite what learned in quantum physics about the nature of the universe in years at MIT, I had the impression that biology remained mired in a worldview 400 years old. The biological model still seemed to be based on a classical Newtonian view of matter and energy, solid bodies and separate moving predictably in empty space, and a Cartesian conception of the body as separate from the soul, or mind. Nothing in this model could accurately reflect the true complexity of a human being, his relationship with his world, or, more particularly, with his conscience. Humans and their parts were still treated for all purposes as machines. Most biological explanations of the great mysteries of living things try to understand the whole, dismembering it into increasingly microscopic parts. The body is supposed to assume its shape due to the genetic information to the protein synthesis and the blind mutation. According to neuroscientists at the time, consciousness lay in the cerebral cortex, the result of a simple mixture of chemicals to brain cells. The chemicals were responsible for the television on in our brain, and also, what we have seen it. We know the world because of the complexities of our mechanism. Modern biology does not believe in a world that is essentially indivisible. In his quantum physics work at MIT, Ed Mitchell learned that at the subatomic level, the Newtonian view, or classical, that says everything works in a predictable, reliable and therefore measurable way, there was a lot had been discarded in favor of quantum theory, which they maintain that the universe and how it works are not so behaved as scientists used to think. Matter, energy, particle, quantum. Universe. The matter at its most fundamental level, could not be divided into units that exist independently, not even be fully described. Subatomic particles were not small solid objects like billiard balls, but packets of energy that could not be quantified or understood in themselves accurately. Rather, they were schizophrenic, sometimes behaving like particles, a certain thing and confined to a small space, and sometimes as wave, something vibrant and more diffuse spread over a large region of space and time. And at other times behaved as both wave and particle. Quantum particles were also ubiquitous. For example, to move from one energy state to another, the electrons seem to be experiencing while all new orbits possible, as someone who wants to buy a house and is trying to live in every house on the block at once to choose from which will finally settle. And nothing was certain. There was defined sites, only the possibility that an electron, say, could be in a certain place, no guaranteed occurrence, but only the probability that it could happen. This level of reality, had not certain of anything. Scientists needed to be satisfied with the fact that you can bet on possibilities. The best that could never be calculated was the likelihood that, when you took a measure, would get particular results in a certain percentage of the time. Cause and effect relationships that were no longer valid at the subatomic level. Atoms to be stable could suddenly, without any apparent cause, try an inner disorder. Electrons, without any reason, decide to move from one energy state to another. After observing more and more closely at the matter, it was no longer matter, was not a solid thing you could touch or describe, but a lot of experimental selves, showing off all at once. Instead of a static sure universe at the most fundamental level of matter, the world and their relationships were uncertain and unpredictable, a pure state of potential, of infinite possibilities. Scientists took into account a universal connection in the universe, but only in the quantum world, namely in the sphere of inanimate things, and not the living. Quantum physics discovered a strange property called non-locality in the subatomic world. The interconnection. It refers to the ability of a quantum entity such as an individual electron, influence instantly another quantum particle distance, without even having been no exchange of force or energy. She indicated that when quantum particles come into contact with each other, they maintain a connection even if separated, so that the actions of an ever will influence each other, no matter how separate. Albert Einstein decried this mysterious action at a distance, which was one of the main reasons why he suspected of quantum mechanics, but this has been definitely confirmed by a number of physicists since 1982. The non-locality has shaken the foundations of physics. The matter could no longer be examined separately. Shares need not have an observable cause in an observable space. The most fundamental axiom of Einstein was not correct. At some level of matter, things could travel faster than the speed of light. Subatomic particles not enclosed no meaning as isolated entities but can only be understood through its relationships. The world, in its basic essence, existed as a complex network of interdependent relationships, forever indivisible. Perhaps the most essential component of this interconnected universe was living conscience who was watching. In classical physics, the experimenter was considered a separate entity, a silent observer behind the glass, trying to understand a universe that moved on, whether he was watching or not. Quantum physics, however, found that the state of all the possibilities of any quantum particle collapsed in an entity so it was observed or when a measurement was made. To explain these strange events, quantum physicists had postulated that there was a participatory relationship between the observer and the observed object. These particles could only be considered likely to exist in space and in time to be disturbed, and the act of be observed and the measures required to assume a defined state, a similar act to the solidification of a gelatinous substance. This astonishing observation also had devastating implications for the interpretation of the nature of reality. She suggested that the consciousness of the observer gave life to the observed object. Nothing in the universe existed as a thing effective regardless of our perception of it. We create our world every minute of every day. Crucial issues. But neither classical physics or biology were able to explain fundamental questions, why we are able to think, why the cells are organized the way they do, how many molecular processes occur instantaneously virtually, why arms develop as arms and legs as legs, although they have the same genes and proteins, for which we contract cancer, for that our machines can miraculously heal itself, and even what is knowledge, we know what we know. Scientists perhaps knew in detail the screws, pins, hinges and various machinery, but knew nothing about the force that provides power to the machine. They could deal with the tiniest mechanical structures of the body, but still showed up ignorant of the most fundamental mysteries of life. If it were true that the laws of quantum mechanics also applied to the world as a whole, not just the subatomic world, biology and not only the world of matter, the whole paradigm of biological science was flawed or was incomplete. Just as Newton's theories had over time been improved by quantum theorists, perhaps Heisenberg and Einstein themselves were wrong or only partially right. If quantum theory were applied to biology on a larger scale, we would be seen more as a complex network of energy fields in a sort of dynamic interaction with our chemical cellular systems. The world would exist as an array of indivisible interrelation, just as that experienced in outer space. What was missing in classical biology was an explanation for organizing principle to human consciousness. The light of the sea. All quantum physicist is well aware of the zero-point field. Quantum mechanics has shown that there is no vacuum or nothing. What we tend to imagine as an absolute void if all the matter and energy were taken from space is, if we examine even the space between the stars, well, from subatomic perspective, that is, a swarm of activity. The uncertainty principle developed by Werner Heisenberg, one of the main architects of quantum theory, suggests that any particle ever stays completely at rest, being in constant motion due to a ground state energy field that interacts continuously with all subatomic matter. It means that the universe's basic substructure is a sea of quantum fields that cannot be eliminated by any known law of physics. What we believe to be our stable, static universe is actually a seething maelstrom of subatomic particles that temporarily come to life and cease to exist. Although Heisenberg's principle refers most notably the aggregate uncertainty to the measurement of the physical properties of the subatomic world, it also has another meaning. We cannot know simultaneously the energy and the lifetime of a particle, so that a subatomic event occurring within a minute time interval involves an uncertain amount of energy. Basically, because of Einstein's theories and his famous equation E=mc2, which relates energy to mass, all elementary particles interact with each other, exchanging energy through other quantum particles, which are believed to arise from nowhere, combining and annihilating one another in less than a minute 10 seconds 23, to be exact, causing random fluctuations energy without apparent cause. The transitional particles generated during this brief moment are known as virtual particles. They differed from real particles because they are only during this exchange, the time of uncertainty allowed by the uncertainty principle. This subatomic tango, however brief it may be, when added throughout the universe, it gives rise to enormous energy, greater than that contained in all matter in the world. Also called by physicists the vacuum, the zero-point field has been called the zero because the fluctuations in the field are still detectable in absolute zero temperature, the lowest possible energy state, from which all matter was removed and supposedly there is nothing left to do any movement. The energy of ground zero was the energy present in the empty state space at the lowest possible energy, which no other power could be removed, the closest that the movement of subatomic matter reaches zero. However, because of the uncertainty principle, there will always be some residual agitation due to the exchange of virtual particles, which had always been ruled out because he is eternally present. In physics equations, most physicists use to remove the problematic zero-point energy, a process called renormalization. 3 as the zero-point energy was always present, he said the theory, it did not change anything. How did not change anything? It was not taken into account. Strength and magnetism. Imagine taking a charged subatomic particle and attach it to a small spring frictionless as physicists like to do to calculate your equations. It should jump up and down for a while and then at a temperature of absolute zero, stop moving. The physicists from Heisenberg has found that the energy at the point of zero field continues to act upon the particle so that it never reaches the home position, remaining to move continuously over the spring. 6 To counter the objections of his contemporaries, who believed in the empty space, Aristotle was one of the first to argue that the space was actually a plenum, a background structure full of things. Much later, in the mid-19th century, the scientist Michael Faraday introduced the concept of a field with respect to electricity and magnetism, believing that the most important aspect of energy was not the source, but the space around you, as well as the influence on one another by means of some force. In the opinion of Faraday, the atoms were not hard like billiard balls, but the most concentrated center of a force that would extend the space. A field is a matrix or medium that connects two or more points in space, typically by means of a force such as gravity or electromagnetism. The force is generally represented by ripples in the field. An electromagnetic field, using just one example, is formed by an electric field and a magnetic field crossing, sending energy waves at the speed of light. An electric and magnetic field forms around any electrical charge which is simply a surplus or deficit of electrons. Both the electric field and magnetic have two polarities, positive and negative, and both will make any other charged object is attracted or repelled, depending on the loads being opposed, one positive and one negative, or the same both positive or both negative. The field is considered to be the area of the space where the cargo and its effects can be detected. The electromagnetic field notion is a convenient abstraction invented by scientists and represented by lines of force, indicated by the direction and by the way, to try to understand the seemingly extraordinary actions of electricity and magnetism, and its ability to influence objects' distance, and, technically, to infinity, without any detectable substance or matter between them. For simplicity, a field is a region of influence. As described by two researchers, every time we use our toaster, the fields around it disturbing, slightly energized particles in the most distant galaxies. Physical Seek a Unified Field Theory. Marcello Gleiser, professor of theoretical physics at Dartmouth College in Hanover, United States, and author of The Dance of the Universe. Why do scientists are so fond of a theory? The answer is simpler than it seems. Theories organized, concise and precise facts that are observed in the laboratory and beyond. A good theory should be able to explain a number of phenomena observed in nature and also to predict the existence of new phenomena to be observed in future epochs. For example, contrast the theory of universal gravitation of Newton and Einstein's general relativity. Although both treat the gravitational phenomena, they do so distinto and quanto. Newton's theory describes gravitation as an action at a distance, E as a force that crosses mysteriously empty space. Einstein proposed that the gravitation can be explained by a geometric treatment in the presence of a massive body deforms the geometry of the space in the gravitational Volta, a geometrization phenomenon, and its success has had a profound impact on the rest of Einstein's life. If gravitation can be explained elegantly by a purely geometric description, why not electromagnetism, the only other force that, like gravitation, also has far-reaching? Until his death in 1955, Einstein searched for a geometric formulation that not only explained the electromagnetic phenomena, but also to unify gravitation. A unified theory of gravitation and electromagnetism is gravitational and electromagnetic phenomena as manifestations of a single force, or more precisely, a single field, the unified field. Every force is associated with a field. If we put a nail near a magnet, we feel the presence of the magnetic field. Field is a spatial manifestation of the presence of a certain fond idea of unification is fundamental in physics. The power or effectiveness of a theory can be measured by the amount of various phenomena that she can explain. Newton unified celestial physics of gravitational phenomena in the terrestrial gravitational phenomena. In the 19th century, Faraday, Maxwell and others have shown that electric and magnetic phenomena can be described jointly by the Einstein field. Electromagnetico Pesar have failed in their mission, their influence lives on today. The idea of unification of forces is one of the most popular among theoretical physicists worldwide. Electromagnetism and gravitation are added to other forces that manifest themselves only subatomic distances, which are the strong and weak nuclear forces. The four forces describe, in principle, all the observed phenomena, from microscopic scales to the macroscopic. Therefore, the theory of everything would unify the four fundamental forces in a single, unified force. This unification is manifest only at extremely high energies, much higher than we can test in today's laboratories. Behind the physical reality, visible only at very high energies, there is another reality, where everything is a manifestation of a unified field. In their intimacy, nature is extremely simple. The idea of unification of the four fundamental forces is not absurd or influenced by monotheistic tendencies, as it may seem. We have already managed to unify the electromagnetic and weak forces, as evidenced experimentally in 1983 by Carlo Rubbia and his team in Geneva, based on theoretical predictions of S. Glashow, A. Salam and S. Weinberg. The energy is about 1,000 times larger than nuclear. The electromagnetic and weak forces manifest themselves as a single force, the electroweak. The next step is to include the strong nuclear force and eventually gravitation in this unification. Perhaps Einstein's vision was not just a fantasy. The aim of modern science is to gain a complete knowledge of natural law and unite this understanding within a single perspective. In recent years, rapid and significant knowledge have emerged in order to unify our understanding of the laws of nature and lead us to an understanding of how the unified field of all these laws are expressed in the manifest level, the various structures of law natural observed in the creation, and describe the vast ramifications of CIA.NA physical area during the 40s and 50s. The theory of quantum field was developed in that elementary particle interactions such as the electron or the proton could be understood. The quantum field theory reveals the existence of a state of minimal excitement in the field, the vacuum state, an unlimited, unmanifested state of perfect order and infinite correlation, which is the basic state of the laws of nature governing the quantum field. The vacuum state of quantum field is a field of all possibilities. Although immutable, he is the source of all phenomena. Changing Campo Por back in the 60s. The entire spectrum of natural phenomena was understood from the four derivation fundamental forces of nature: electromagnetism, gravity, strong interaction and weak interaction. Since that time, there was great success at an older unification of knowledge of these fundamental forces. First the weak interaction and electromagnetism were unified, then this unified theory of electromagnetism and the weak force were combined with the theory of the strong interaction in a theoretical framework called theories of the Great Unification. In quantum world, quantum fields are not mediated by strength, but by exchanging energy, which is constantly redistributed in a dynamic pattern. This constant exchange is an intrinsic property of the particles, so that even the particles real are nothing more than a small cluster of energy that emerges for a short period of time and return to fade in the underlying field. According to quantum field theory, the individual entity is transient and insubstantial. The particles cannot be separated from the empty space that surrounds them. Einstein himself acknowledged that the matter was extremely intense in a sense, a condition of perfect randomness, and that the only fundamental reality was the underlying entity, the field itself. Fluctuations in the atomic world correspond to a constant pass energy from one side to the other, like a ball on a ping-pong game. This energy exchange is analogous to lend a penny to someone, we are a poor set, and the other person a penny richer, until she pays the dime back and the roles are reversed. This type of emission and absorption of virtual particles occur not only between photons and electrons, but in all quantum particles of the universe. The zero-point field is a repository of all the fields, all the fundamental states of energy and all virtual particles. One course is course. Every exchange for each virtual particle radiates energy. The zero-point energy in any particular transaction in an electromagnetic field is unimaginably tiny, half a photon. But if we add all the particles of all varieties in the universe who are constantly acquiring life and ceasing to exist, we find ourselves faced with a vast and inexhaustible source of energy, equal to or greater than the energy density in an atomic nucleus, quietly positioned in the background. The empty space around us as a diffuse and overwhelmed backdrop. It was calculated that the total energy of zero field surpasses the energy field by a factor of 1040, or 1 followed by 40 zeros. Once described as the great physicist Richard Feynman in trying to explain an idea of this magnitude, the energy in 1 cubic meter is sufficient to boil all the oceans of the world. Light team is invincible.